All right, ladies and gentlemen, we today are going to go over compound interest. It's going to be great. So before we dive into the actual problems, let's get some formulas down, so you can use them and stuff. All right, formula time. Blam! Here's one. This is how compound interest is computed. All right, let's go over this whole thing. So A is just the final amount after however many years or whatnot. P stands for principal. That's just what they call the amount of money you start with in the account. And then inside we got 1 plus R divided by N to the N times T power. This R is the interest rate as a decimal. You need to make sure things are as a decimal here. And then N is the number of times it compounds each year. So what compounding is so let's say you have a percentage rate for the whole year. It's like maybe you got 5% growth. What happens with banks and a whole bunch of other accounts is that they compound, as in they give you a part of that interest throughout the year and not just once at the end of the year, right? And so it's pretty common for your savings accounts and checking account, mortgages, things like that they'll compound each month. So maybe you have a 5% interest rate for the year, but they don't give you 5% just once. They'll take 5% and divide it over the 12 months, which is, I don't know, something pretty small. And then they give you a portion of that, right? They give you a little bit less than 0.5% each month added to your account. And so it compounds multiple times in the year, not just once at the end. So that's what compound means. Hopefully this equation looks familiar because we had previously that we have something like y equals a times 1 plus or minus r to the x power. This is very, 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 very similar. Instead of just r here, instead of just x, you split the r up into however many times you compound it, and you do that however many times during the year. So if you're compounding 12 times a year, n becomes 12, and you'll do 12 times however many years it's been. Okay? And so that's how you use your formula. You put the number of compounds, you put their interest rate, and then how many years, and you can compute a bunch of things. Well, in the principal. Okay, so there's a first thing. There's going to be another note thing to write down in just a moment. Scrolling past it. We're going to now do number 1. So Bobby and Greg are investing $10,000 into a money market account that pays 5.5% interest quarterly. Nice. How much money will they have after 5 years? So we're going to use our account. The amount equals the principal, which is $10,000. And then we got 1 plus our interest rate, which is 5.5, but as a decimal. So we need to take this and divide by 100, because percent means out of 100. And that's going to give you 0.055. And so we're going to get 0.055. And this is going to be divided by how many times it compounds during the year, and that's 4. It says quarterly. That means 4 times throughout the year. And then in the exponent here, we need to do 4 again, and we're going to times it by how many years, which is 5. So 5 there. And ta-da! That's what you're going to put in your calculator. It's got all sorts of fractions and parentheses and exponents and stuff. And so be very careful when you put it in your calculator. I'm going to show you how to put it in the decimal one, but you can use just the TI-84s in class to get it computed. So I'm going to bring up this Desmos scientific calculator. Scientific. All right, I'm going to do 10,000, and I'm going to multiply by parenthesis 1 plus, and I'm going to do 0.055 divided by 4, and then I'm going to come over here and close my parenthesis, and now I'm going to do exponent. To do exponent, it's this button here on the left, in the left section, a to the b power. That's how you do exponent. So you click that, hit Oh, no, I'm breaking stuff. All right, let's go back. A to the b power. My goodness, why is it doing this? Stop being unruly. All right, to that power. Okay, perfect. It's because I held my finger on it once. Okay, sheesh, that was a chore trying to get the exponent there. Anyway, now I'm going to do 4 times 8. You need to make sure it all stays in the exponent there. You may need to add parentheses to the 4 times 5 power. Excellent. And then you can push enter, and it gives you on the right side here our number of 13,140.66502. So I'm going to come over here to my assignment, and that is going to be a rounded thing. Okay, I need to look at it again. 13,140.66502. 665 is rounded 0.67. And since this is money, we're just going to round to the second decimal place. And ta-da, we did it. We found out how much money. And this, by the way, should say compounded quarterly. It doesn't give things don't usually give you a set amount of percent each quarter. They'll do it yearly and compounded when. Anyway, so is that. So now we're going to do 2. And on 2, it has this fancy phrase where it says compounded continuously. So instead of compounding like once a month, once every quarter, or even every day, what this is, if it's compounding continuously, it is compounding every second of the day. It is compounding all the time. So you inhale a breath, it has compounded a little bit extra money into that account. And so it's this continuous giving you the interest throughout the year, which is kind of an interesting phenomenon, but you can set it up. And what that does is you actually have to use a slightly different equation. And I'm going to show you what that looks like. It looks like this. This is for compounded continuously. The amount equals the principal times e to the RT power. This R is still your rate as a decimal. This T is still your years. This is still your principal. But then you got this thing. This thing is called E. And E is a constant. This is Euler's number, and not like Euler. It's it's a mathematician, Euler. Euler's number. And it is a constant. It's like pi. It's this infinitely long decimal number, which I don't know why we don't celebrate E Day, but we should celebrate Pi Day and E Day. But here's where it comes from. This should look somewhat familiar. This is compounding however many times throughout the year. Right, compounding 12 times a year or quarterly. And if you take the limit, by the way, this is a calculus concept. Take the limit. If n was infinity, you're compounding an infinite number of times throughout the year. You get this thing, which is E, which is, here's a decimal approximation. It goes on forever, by the way. So I should put some more dots here. It's about 2.72. We're going to use this equation for all the compounding continuously problems. So let's go to 2. This is a compounding continuously problem. So the amount is going to equal the principal, which is 5,000, times E to the RT power. The R value is this, but again, as a decimal. So 6.5 divided by 100, you get 0.065. And we're going to times by T, which in this case is 10 years. So we're going to times by 10. And again, this is something you can put in a calculator. Calculators have E in there. And so we're going to do that. We're going to pull this up. Let's clear everything out. Clear all. Oh, crap. How much did we invest? $5,000. So we got $5,000. We're going to times by E. You may have noticed there's not an E here. If you have your keyboard handy, you can actually just put E. It knows what's going on there. Or if you go to function, F-U-N-C, there's E over here on the right side. It's right next to pi, because E and pi are kind of friends in a lot of ways. You can do E, And now we need to do the exponent. So I'm going to push my exponent again. It was 0.0. Hey, 0.0. What was it? 65. And I'm going to times. Oh, I need to do parentheses again, don't I? Put some parentheses. I'm going to times by 10 because it's 10 years. And enter. I said enter. Hooray! And we got our answer. It's over here on the right side. $9,577.70.4145. So yeah, let's go ahead and write that down. And I already forgot it. 9,577.4. Is it just? I'm gonna round in the second decimal place. It's 70. So erase this. 70 dollars. Hooray! We did it. That's how much money is gonna have. You compounded continuously 6.5% throughout yearly rate. So we got that. Awesome. So that's what's going on with your assignment. With a lot of these interest problems, it's just how many times is it compounding? You need to get a certain value. What is it after a certain number of years? So you're using a calculator a whole lot. You can use the decimals calculator. You can use just the hand calculator, and that's fine. We're going to get to how to use a graph for things in another video. But there's one other thing I want to touch on, and that's problem 10. So your problem 10 doesn't look like this. It doesn't have this box. And that's because I copied and pasted some things from notes. And I'm going to kind of talk to you what about effective interest rate means. So usually when you're given a problem and it tells you 6.5% rate, that's the annual rate. And the thing is, when you compound it more than once a year, it actually gives you a little bit more than that rate if you look at it over the whole year. And that's because it's giving you a little bit, and then when it compounds again, it gives you even more because you already have a little bit more in that account. And so if you have a monthly compounding of 10%, you actually get a little bit more than 10% over the whole year because you're compounding the thing you've already compounded, and you get a little bit extra. And so what you need to do, a lot of these on the back, is you need to find this effective rate, the effective rate. And here's how you do it. And we're going to use 10 as an example. So here's my investment, $235,000. I had an interest rate of 22.351%, and it's compounding monthly. So my N is 12. Well, I'm going to start filling this in. Just my normal equation. Here's my interest rate. As a decimal, it's compounding quarterly. And I got 12t there. If you want to get the effective rate, you're going to ignore this, ignore the t value, and you're just looking at what's in the parentheses and then to the n power. Right? This 12 is the number of times it's compounded. So if you compute this, it's going to give you a decimal 1 point something. And that's the percent more. That's the percent of the original that you have. And so you need to subtract 100% from that, or subtract 1 from it. And it gives you the percent increase there. So let's go ahead and compute this. Again, I'm going to use my decimals calculator. I'm going to put in parentheses 1 plus 0.22351 divided by 12, close parentheses, to the 12th power. So this is kind of a lot to put in there. I'm going to clear this out, though. Parentheses are our friend, though. 1 plus 0. Oh, goodness. 22351 divided by 12. I'm going to close this parenthesis. I'm going to use the exponent button and use parenthesis. Oh, I guess I'll do that. And it's compounding 12 times a year, so I'm going to put 12 in my equation here. Just put 12. Not 2, 12. And close it, and I'm going to push enter. And I get this number here on the right side. 1.247988979. It gives you a long number there, okay? So I'm going to write it out. It's 1 point. Let me look at it again. 2478. 2478. 897. I'm going to stop there. 8, another 8, 7. Okay. So this is what you would be timesing your principal value by, so it's getting bigger. But this would represent 124.78%. But that's not your effective rate. It's not 124%. You're going to subtract off 1. You're going to get your decimal 0.2478897. And it does keep going. And we're going to convert this to a percent. Use times by 100. And you get 24.788. And let's just round to the second decimal place here. So 0.79. This is our effective rate here. So you're taking your normal equation, but you don't put in the principal, and you don't put in the years, and you just compute what is here. And that gives you a number, 1 point something, subtract off the 1, and the extra amount is the effective rate for that year. So there's your answer for 10, and that's how you get effective rate. So there you go. Interest, number 1, kind of things you can do. We're going to get into how to use graphs to help you solve things in the next video in dealing with interest number 2.